Hey party people, it's Miss Press here. We're here to talk about algebra today. Specifically, we're going to be covering topic 2C, which deals with finding a linear equation. So let's go ahead and look at our reference materials first, because I want to highlight some important formulas. Specifically, let's go on down to the linear equation section. All right, we've got a few different forms and formulas for linear equations down here. First is standard form. Standard form, we're not often asked to find things in standard form, but just in case we are, it's important to note that your x and your y can often be translated to a point in a function, x and y. In fact, you're going to notice in every single form, an equation of a linear function, we have an x and a y. Those translate to our input and output, and we'll look at those on a graph in just a second. Going to a very common form, we've got slope-intercept form, everyone's favorite, y equals mx plus b. And slope-intercept form is aptly named because it contains a slope and an intercept. Sometimes you'll also see this written as f of x equals mx plus b. Don't be scared that the f of x and the y both just mean the output of a function. All right, then next up, point-slope form, also aptly named because it contains a point and a slope. Your slope, again, is the m. Don't ask me, I didn't name it. And your point, x1, y1. Again, we have that famous x and y. The last thing we're going to note down here is the formula for the slope of a line. Again, the m stands for slope. And here you have 2 points. So whether you're given 4 points, 7 points, 10 points, 2 points, you can find the slope of a line picking just 2 of those points that are going to be x1, y1, and x2, y2. Focusing in on that point right there, on that piece of information right there, I'm going to go ahead over to an example question. All of this, by the way, is on your reference materials that you'll be given on the test. You don't have to keep it in your brain, but let's see how this applies. So I have a graph here. It says the graph of a linear function is shown on the grid. As soon as I see the word linear, my mind is going right over here to linear equations. And it says which equation, look at that, is best represented by this graph. And there's more than one way to find the equation of a linear function when it's represented graphically. I'm going to show you guys my favorite way. Some of you all might remember rise over run. I'm finding 2 points that fall perfectly on corners, and you could count the rise over run. But I find that ends with a lot of errors for me. I forget which way I'm counting. I make mistakes with the direction. So what I'm going to do is I'm going to use 2 points. I'm going to treat these 2 dots like 2 points have been given on the line. This is 0, 5. This is 2, -1. And those are going to translate to my x1, y1, because every point has an x and a y, an x and a y, an input and an output. And then we've got 2, -1, which is my x2, y2. Now I can use this slope formula over here, and I'm going to plug those in. M equals y2 minus y1 over x2 minus x1. It's going to give me -6 over 2 is -3. I know my slope is -3. Now looking over at these options, they look so scary and confusing until I realize they're all just written in point slope form. So I know that this number in front of the parentheses is going to have to be my slope. I'm looking for functions that have a slope of -3, which means I can eliminate choices C and D. And I'm between these 2 choices. Now I need to look at the point that I'm given. I need to remember that point slope form is y minus y1 equals m times x minus x1. This is very important that these are negative, which means that if I plug a negative value into here, because I will be subtracting a negative, I will end with a positive number. So I'm going to check my points here. That means that this 7 is actually a -7, and this 4 is a +4. So this point is going to be 4, -7. 4, -7. That is a point on my graph. However, 2, -2, -1 is not.